Hello Algebra 1 students, this is lesson 25 and our objective for today is what is the difference between a function and a relation and how can I tell? So I guess let's just jump into those definitions and see if we can kind of grasp those at least somewhat, and we'll see if we can understand them a little more. A relation is just a set of ordered pairs. So it's just an x with a y. They're being paired together and there's a set of them. So there's a domain and a range, and each domain, so each x number, is paired with an element or a number in the range. So if you want to say, 1, 2, 2, 3, 3, 4, 4, 5, that'd be an example of a relation. Now, there's a specific type of relation called a function. And a function is a relation where each element in the domain is paired with exactly one element in the range. And that exactly one is what is key. This is paired with exactly one. So let me give you an example of what a function might look like. We are here in Oklahoma, and we want to fly to Madro in the Marshall Islands. So we get a plane ticket, and we get on the plane, and we fly to Madro. The fact that this airplane has only one destination, Madro, means that this trip, this function, or this relation, is actually a function because it only has one destination. So Oklahoma goes to the Marshall Islands. Now, something that would not be a function is if we start here in Oklahoma, and we get on the airplane, and you taxi on the runway, and they take off, and the pilot comes in the intercom and says, well, thank you for flying with whatever company you're flying with right now. We're either going to fly to Madro or to Hawaii. I haven't quite decided yet. I'm going to flip a coin and we will see where we will go. That would be a problem because you already have hotel reservations and you're going to see family and friends there in Madro. You don't necessarily want to go to Hawaii because you don't have either of those things. So that would be a problem because this trip from Oklahoma is either going to Hawaii or it's going to Madro, and that is a problem. If the same input goes to two different outputs, that's a problem. We don't want that. We want to know always exactly where we're going in order for it to be a function. So let's just practice a little bit here, being able to identify our domain and our range from ordered pairs, and then also being able to tell from ordered pairs, is this a function or not? So first of all, our domain in the ordered pairs is always the first one. So I'm just going to go through and highlight those in red. So this is the first one here. These are all of the domain. So what we're going to do is I'm just going to go through and write them, and normally we write them from the smallest to the largest as a set. So we're going to use our squiggly brackets. The smallest one in there that I've highlighted is -3, -2, -1, and 0. Now the range is always the second number, so 0, 0, 3, 1. So let's again write those. So start with the smallest number, which is -1. And then we go up to 0. And we've already mentioned 0, so I don't need to mention it again. And then 1. So notice again, we had 2 zeros, but we only had to write it one time. These are all of the elements, or all of the pieces that are in the range. Now let's try to decide if this is a function. So let's look right here at -2. The number -2 takes me to where? 0. Does it take me anywhere else? So as we look through here, does -2 go to any other number? No. So then so far, that one checks out. Alright, let's go here. What about -3? Does it take me anywhere else? It takes me to 0. Doesn't take me anywhere else. So that means this one does check out. Now, some people might be saying, but Mr. Siri, -2 is already going to 0. -3 can't go to 0 too. Well, that's actually okay, right? If I'm on this plane I know my destination. I'm going to Madro. I don't have a problem with it if someone else is on a different plane and they also fly to Madro, as long as I know where I'm going. And this plane, they would want to know for sure where they are going. But it's okay that there's two different numbers flying to the same place. It's still a function. Continuing on, -1 only takes me to 3. Does -1 take me anywhere else? No, it doesn't. It only takes me to 3, so then that would be, still holding true there. And the last one, 0 takes me to 1. This red element doesn't take me to any other place, just to 1. And so then that one also checks out. So is this a function? I'm going to say yes. This is a function. Okay. Let's look at this here. Same idea again. Highlighting all of the parts in the domain with red. So I have 1, 2, 9, 6, and 4. So let's write all of those. It'll be 1, 2, 4, 6, 9. And then for the range, 7, 3, 5, 3, and 9. So the smallest one in there is going to be a 3. There's another 3, but I've already mentioned 3. So then 5 is the next one. 7 and 9. Is the function. You can go through the same process before. 1 goes to 7. There's no other 1s to take me to another place. 2 goes to 3. There's no other 2s to take me to another place. 9 goes to 5. There's no other 9s to take me any other place. 6 goes to 3. There's no other 6 to take me to another place. So this is a function. Yes, this is a function. Happy face. Okay. Now I will mention just real quick that it would still be the same set if I didn't write them in ascending order, but you on your homework will be writing those in ascending order. Otherwise we'll have to mark them off. We just want to enforce those good habits. So use squiggly brackets, smallest to largest, and that's the way we're going to write them on our homework. Alright, now there's another way to tell if a relation is a function. And I've drawn 6 different pictures here of functions. Some of them are kind of just here with single points, like a finite number of points, I can count them. Some of them are like an infinite number of points that are so close together that they look like lines. Okay, but let's still just see if we can go through and see if these are functions or not. So let's start with this first one here. My x at this point is -6 and my y is 0. Is there any other place that this -6 would take me? So I'm going to look above and below. There's no other points there. Moving on, -5 only takes me to 5. Doesn't take me anywhere else. -4 only takes me to -2. -2 takes me to, I'm going to say -1. 0 takes me to 0. Remember, this is 2 planes flying to the same place. That's okay. 1 takes me to 1. 3 takes me to 2. 6 takes me to 1. Again, 2 planes flying to the same place, but that's okay. So notice, this is a relation. So are these functions? This one I'm going to say yes. It is a function with a happy face. Now what about here on B? So -6 takes me to -4. -5 takes me to 2. -3 takes me here. -1 takes me, 0 takes me to 1. But as I look up above this, look at this. 0 also takes me to 4. So if I get on the 0 plane, I don't know if I'm going to 1 or if I'm going to 4. That pilot is going to be flipping a coin. So is this one a relation? This one is no. This is not a function. It is a relation, but it's not a function. Okay, now let's get to some with some infinite points there and just see what that looks like. how we do that. Let's just pick one here randomly. If I put in -2 into my function, I could get this number, which is like 2.5, or I could get this number, which is -2. So it's kind of like here where I have 2 points above each other. Okay? So is this a function? No, because as I put a -2, I could be going up here, or I could be going down here. So is this a function? No, it's not. No, it's not. Now maybe you've started to see a pattern in ones that look like functions and ones that don't, and that is what we call a vertical line test. A vertical line test simply means that if you draw vertical lines, which is, remember, going up and down like that, if it touches more than one point, then it's not a function. If it only touches one point, or no points, then it is a function. Now just know that if any vertical line that I draw touches 2 points, then we say no, even if you can find some that only touch one. So notice over here, as I draw these vertical lines, all these lines only touch 1 point. But as I come over here, this one only touches 1 point, only 1 point, only 1 point, but this one right here, notice it touches it right here, and touches it right here. So that's why we said no. So even though the rest of them only touch at 1, if there's one of them that touch 2, then we say no. Same thing over here. As I draw these, notice it touches it here and here. I could draw one that only touches at 1 point right there. But the fact that I can find one that touches at 2 points, or in this case I can find several, and that's why I said no. So let's kind of apply that same principle here. What if I start drawing vertical lines here? Notice that line only touches there. Only touches here, only touches here, only touches here, only touches there. So no matter what vertical line I draw, it only touches at one place. So then I would say yes. Happy face. What about this one? Well, as I'm drawing vertical lines, notice they're only touching in one place, so I'm going to say yes. What about over here? Well, this vertical line only touches in one place. That's okay. This one doesn't touch at all, but that one touches in 2 places, so I'm going to say no. Frowny face. Your homework is down here at the bottom, all 25, all 24, plus 12 more of your choice. Good luck, I'm sure you're going to do great.